Welcome to Go Lesson 34. Today we learn Gorm, the most popular ORM for Go. Connecting, CRUD, associations and advanced features. GORM maps, Go structs to database tables. Let us start with the basics of connecting to a database using GORM. We import two packages. The Go SQLite package is a pure Go SQLite driver, built specifically for GORM. The gorm.io/gorm package is the ORM itself. The user struct embeds gorm.Model, which adds 4 fields automatically: ID, CreatedAt, UpdatedAt, and DeletedAt. You only define your business fields. Gorm.Open takes a dialector and a config. sqlite.Open creates a dialector from a file path. Much simpler than raw database/SQL. AutoMigrate reads the struct and creates the database table to match. No manual create table needed. db.Create takes a pointer to a struct and inserts it. The ID field is automatically populated after the call. We create a second user the same way. Notice how clean this is compared to writing raw SQL with question mark placeholders. db.First fetches one record by primary key. GORM scans the result directly into your struct. No manual column scanning required. db.Find loads all records into a slice of structs. The len function tells us how many rows were returned. To close the connection, we get the underlying sql.db and call close on it. Let us review the complete code before running it. The pattern is straightforward. Define a struct, open a connection, auto-migrate, and use create and find for data access. Now let us run the program and see the output. GORM auto-populated the IDs after each create call. The find query returned both users stored in the SQLite file. Now let us implement full CRUD operations with GORM. We will see how much simpler it is compared to raw SQL. The to-do struct embeds gorm.Model, just like before. The done field is a boolean that GORM maps to a database column automatically. The printall helper uses db.Find to load all to-dos into a slice. No manual row scanning or iteration needed. We use a checkbox display with X for completed to-dos and a space for pending ones. For this demo, we use an in-memory database with the memory connection string. db.Create accepts a slice to batch insert multiple records at once. GORM generates a single efficient insert statement. The update method changes a single field. We chain where to specify which record to update. This generates an update set where query. Updates with a map changes multiple fields at once. Here we rename the to-do and mark it as done in one operation. db.Delete performs a soft delete by default. Since our struct includes gorm.Model with a DeletedAt field, gorm just sets that timestamp instead of removing the row. Where queries filter records just like a SQL where clause, gorm still excludes soft deleted records from normal queries. db.Unscoped bypasses the soft delete filter. Now we can see all three records, including the deleted one, marked with a deleted tag. To permanently remove a record, call delete on an unscoped query. This actually removes the row from the database. Let us review the complete code. Notice the pattern. Each gorm method maps directly to a SQL operation, but with much less boilerplate. The bat review shows the soft delete and unscoped patterns clearly. Now let us run the program. Watch how each operation is verified with a full listing. Soft delete hides the record, but unscoped reveals it. Now let us explore associations. GORM supports has many, belongs to, and other relationship types. The user struct has a posts field, which is a slice of post. This tells GORM that a user has many posts. The post struct includes a UserID field and a user field. UserID is the foreign key, and the user field lets gorm load the associated user. GORM follows a naming convention. A field named UserID automatically references the user table's primary key. No tags or configuration needed. We auto-migrate both models. Gorm detects the relationship and creates the foreign key constraint in the database. When we create Alice with nested posts, GORM inserts the user first, then inserts each post with the correct user ID automatically. To add a post to an existing user, set the user ID field. GORM inserts the post and links it to Bob. db.Preload tells gorm to load associations in a separate query. Without it, associations are not loaded. Here we preload Alice's posts. GoRM runs a second query to fetch all posts where UserID matches. Preload works in reverse too. We load a post and preload its user to see who wrote it. Without preload, the post slice is empty. GoRM uses lazy loading by default, which means associations are not fetched unless you explicitly ask. Finally, we load all users with their posts. Preload on a find query works the same way, just for multiple records. Let us review the complete code. The key takeaway is that preload is required to load associations. GORM does not join tables automatically. Now let us run the program. Alice has 2 posts from the nested create. Bob has 1 post added via UserID. Without preload, 0 posts are loaded. Finally, let us explore advanced GORM features: hooks, scopes, raw SQL, and transactions. The product struct has name, price, and discount fields, along with the embedded gorm.Model. GORM hooks are methods on your model that run at specific lifecycle points. BeforeCreate runs before every insert. Here it uppercases the product name. The hook receives a transaction pointer and returns an error. If the hook returns an error, GORM cancels the insert. AfterCreate runs after the insert succeeds. The ID is already populated at this point, so we can log it. Scopes are reusable query functions. Each scope takes a gorm.DB and returns a modified gorm.DB with additional conditions. The expensive scope filters products with price above 100. Not discounted filters products where discount is false. We create 5 products in a loop. Watch the console output to see both hooks fire for each product. db.Scopes chains one or more scope functions together. Here we find expensive products first, then combine both scopes to find expensive items without a discount. Scopes compose naturally. Each scope adds a where clause, and GORM combines them with AND. db.Raw lets you write raw SQL when the ORM query builder is not enough. Here we compute aggregate statistics with count and sum. We scan the raw result into an anonymous struct. Gorm maps the SQL column aliases to struct field names. db.exec runs raw SQL for mutations. Here we apply a 10% discount to non-sale items using raw SQL. Sometimes raw SQL is the right choice. Golang does not force you to use the query builder for everything. db.transaction wraps a function in a database transaction. If the function returns an error, gorm rolls back automatically. Inside the transaction, we increase all prices by $10. Then we validate that no prices went negative. If they did, the error would trigger a rollback. Let us review the complete code. This is our longest example with hooks, scopes, raw SQL, and transactions. 5 pages of code. Each section demonstrates a different advanced pattern. The hooks and scopes patterns reduce code duplication across your application. Now let us run the program. Watch the hooks fire for each product creation. Scopes filter products by price and discount status. The transaction applies a bulk price increase safely. Let us recap what we covered. Gorm.Open connects to SQLite. Create, find, update, delete handle CRUD. Preload loads associations. Thanks for watching. In the next lesson, we will build a REST API.